Okay, so today we will discuss assignment. The assignment operator, which is the equal sign. So when you are doing assignment, this is not called the equal sign. This is called the operator, assignment operator. Okay, here. That's the assignment operator. So what is an assignment? This is an assignment, okay? This is a variable declaration with initialization because you are declaring the variable, that's the data type, the variable name, assignment operator, and this is the value, initial value you are giving to that memory location. And here you are changing it to 55. You're giving it a new value. That's why we say the value of the variable can change during the program execution. Okay, so an assignment statement changes the value of the variable. The single variable to be changed is always on the left. So this is really very important. Let me move this up. Okay. This is really very important. The variable you want to change is always on the left. This is different from math expressions, okay? So this is on the left of the assignment operator. The value you want to place in that memory location is on the right. Do not think of this as anything else but a memory location. So you are putting that value into that location, okay? And now you want to change that value, the value in that location, you put 55 there. And that value will be in that memory location. So here is, oh, where is it? Suppose this is your memory chip. In one little place, this place is named total, right? That's the memory, that's the name for this location. This location is actually divided into several cells, several bytes. And each byte has a byte number, but we combine these 4 cells, these 4 bytes into one location and name it total. And then when you declare this variable, that means when you request that location from the operating system, you say, okay, I'm requesting this location that can store an int, which is 4 bytes, and then place the value 12 there. So you place the value 12, right? That's this statement, everybody, okay? And then when it executes this statement, it's saying place the value 55 into that location. So this value is erased, and now it's 55. That's what happens. Any questions? Okay, so the expression on the right is evaluated, and the result is stored in the variable on the left. So another thing to remember is you always evaluate the right-hand side first. So evaluate this. This is an int literal 12, and then you place it into that memory location. Look at this. Okay, this is not this semicolon. Okay, just this one, this part. This is a math expression, right? We call that arithmetic expression. It's saying get the sum of the variable height and gap, add them together, and then place that value in this variable location, in that location. So that's what this means. The expression on the right is evaluated. So this addition is performed first, and then it's placed into this location. So addition first, assignment second. Okay, that's the sequence of the operations. The value that was in total before 12 is overall. Okay, I'm explaining this part. We assign a value to a variable that is consistent with the variable's declared type. So if you look at this, the declared type is int, right? And you cannot place a 3.5 there. You cannot say total equals to 3.7. No, because this is a decimal number. We call that a floating point number. And this total is declared to be an int. So that will not do. That's what this means. Okay. Any question? Any questions?
Yes.
Okay,
So,
go ahead.
Dr. Z,
go ahead.
based on what this says, was the value in total before, was that 43?
43.
Yeah. Because it changes to 55. So
Oh, no.
if
Originally, so if this is the location named the total, originally it's 12, right? After this statement, it's 12. And then you execute this statement. Now this 12, it's overwritten, just like a blackboard. It's erased, and now it's 55.
oh, so you're just overriding.
You overwrite it. You don't do any calculations unless it is a calculation like this. Here, it's a simple int literal. There is no calculation. You don't do subtraction or anything. You simply overwrite it, erase that, put the new value there.
Yes, ma'am. Thank you.
Okay, good. Any other questions? Let's look at this.
Have we discussed already the different variable types?
Say it again, Chris.
Have we already discussed the different variable data types?
No, we only discussed string a little bit, and this we declare. Did we discuss string? We declared only int right now. No, we discussed only int, and we will do the other types. Okay, so let's look at this class. Okay, class header, everybody. Beginning of the body, ending of the body. I'm doing this again and again. I don't know if you get numb from this, but you have to remember when you write a program, you cannot just start with a statement. That will not do. You will always have to have a class header, beginning, ending, method header, beginning, ending, and then statements. You have to remember that. This is the third week of the class, everybody. Once the third week is done, guess how much of the semester is gone? 20%, right? We have 15 weeks of classes and 3 weeks is 20%. So it goes by super fast. If you think this is still the beginning, I still have time to catch up. No. So you need to really put in your time and effort into this. Whatever we discuss, you need to study and review and grasp it. Okay, so now this is the method. Inside the method, this is called declaration with initialization, right? Okay. Int type, variable name, give it the value 7. So you have a little space in memory that's called the size, right? Okay, originally it's 7 there, and then you print it out. This is a string. This is called string concatenation here, right? So these two together, a string and a number, one of the operands is a string. So this becomes a string. It concatenates this number. And once this becomes a string, it concatenates with this again also. Okay, so that's what is output. What the output is. A hectagon has 7 sides. Remember that when you reference the variable in your program, the value replaces the variable name. So this becomes 7. Okay. And then we reassign a value. This is called an assignment statement, right? We reassign a value. We assign 10 to that location. So now that 7 is gone, erased, and it becomes 10. So when you reference it again, size, instead of 7, it's 10. And that's what you see here. Okay, and then you reassign a value to it for a second time. That's 12. So now that 10 is erased and 12. Okay, and when you use it here, reference it here, it's 12, not 10 anymore. So 12. Any questions? And this shows you that a variable, the data type cannot change, but the value can change during the program execution. You see, when it executes it, it keeps changing. And when you use that variable, it always uses the current value. The previous values are lost. They are lost. It uses the current value. Any questions? Okay, let me see, look at these examples and exercises, okay? A little bit exercise. Assuming they are executed sequentially, that means one after the other, they execute. So this is called variable declaration and initialization with initialization. So my cost has the value of 56, right? Your cost has the value of 78. My cost equals to your cost. Let me ask you, what is the value of my cost after this statement?
It'll be 78.
78.
78, yes. Okay, so this is doing this, right? So you go to the system, will go to your cost, get the value 78, and place it into the location named my cost. Yes. And now, what about this one? What is the value of your cost now? I am doing this. Okay, so you don't accidentally see the answer. So what is the value of your cost right now?
Would it still be 78?
Still 78.
Still 78. Why?
You never changed the value again?
No, that's not
because
the
it didn't override my cost, so 78.
Yeah, how is it overwritten?
Well, it got overridden in the top, didn't it? It says my cost equals your cost, so my cost is 78, so your cost equals my cost, so 78. So
yes,
yeah.
yes. Okay, so this is going to the variable name, the my cost, and get the value and assign it to it. So it's two, mine, yours. Okay, my cost originally is 56, and your cost originally is 78. After this statement, this is gone, it becomes 78. And then your cost is assigned the value from my cost. So this is gone, and it goes to my cost, get the value 78. Erase that. It's the same value, but it gets it from the my cost location. This original value is still erased, everybody, even if they are the same, it's still erased, and it puts the new value into it. Okay, that's this. Let's look at this. What is wrong with the following statements? Is this correct, everybody? Is this a valid statement?
Yes.
What type of statement is it? What do you call it?
A variable?
No. It's a statement. What statement is this?
Declaration and initialization.
Yes, that's very good. Declaration with initialization. Okay, and this is the same, right? It's correct. This is the same, it's correct. What about this one?
No.
No, why not?
Because the two variables, mine and yours, are being added together, but you can't do that on that side of the statement.
Yeah, it's on the wrong side.
It's on the wrong side. Yes, that's right. Okay, so remember your destination. Okay, this is your destination, right? On the left-hand side is the memory location, the destination. That's where you want to place the value. Okay, destination. So this is the destination and this is the expression. the expression is always on the right-hand side, the destination is always on the left-hand side. So you always, everybody, evaluate the right-hand side first, and then place that resulted value into the left-hand side. So this is in the wrong order. This is more like a math calculation, and that's not right. Okay, in programming language, the destination is always on the right of the assignment operator, and then you have a value or an expression on the right-hand side. Okay, any questions? Yes, let's look at this. No questions, let's look at this. Okay, constants. What does constant mean to you, everybody?
Like a continuation, like it's constantly happening, like it's continually happening.
Okay, a constant, yes?
Same, does not change.
It does not change. A constant doesn't change. Yeah, we all need constants in our life. You know, if you think about it, right? When you're younger, your parents are your constants. They are there no matter what. That's why when you are young, if you lose a parent or both, it's devastating to you, right? Because that's a constant. That's like a safe haven, and it's gone and you feel lost. So constant never changes. In Java, it's the same. It's a constant. That means it's a variable, which is an oxymoron because it's a variable, which means it varies, it changes, but it's a constant, but we don't have any other names for it. It's a constant, okay? It doesn't change. So we express that with this keyword, final, and then the data type, and then the variable name, the constant name. The constant name, notice the condition, the convention, all caps. If in your program you use a lowercase letter for a constant, I will take points off. Okay, so all caps. If it's two words, you use an underscore to separate them so that it's easier to read. If this is a regular variable name, you would write it like this, right? If this is a regular variable, lowercase the first one and capitalize the initial letter of the second one. Oops. So that's in a regular variable name. Here it's a constant, it's different. 50. So once you do this, you cannot change it, okay? So when you reference it, it's 50, right? And then if you try to change it to 100, not okay. Because once it's declared and initialized, you cannot change it. Any questions? This is, I would say, pretty easy to understand. Any questions about this? What you need to remember is your data type is always immediately preceding your variable name. So you cannot do int final, you cannot do that. Okay, you always have to do final and then int. Variable name and int, your data type and variable name have to be next to each other. That's important to remember. The name of the constant should, okay, I already talked about this. Any questions?
So if you try to change the value of a constant, will it like just not compile, or is it gonna like ignore that?
It will not compile, yes.
So to have a final constant, you always put final in, and then the final, and then whatever the constant's going to be in capitalized, and then that will always be your final, your constant.
Yes, if you don't make this capitalized, will it compile? Yes, but it's not the convention, and you don't look professional. So you always want to capitalize your constant name.
And always put final in front of int.
Yes, yes, because if you don't have the final, then it's a regular variable. Even if you capitalize it, it doesn't matter, right? So Without the final, it's a regular variable, whether you capitalize it or not. With a final, it becomes final. Any other questions? Okay, great questions. Let me look at the chat and see. Okay, you're answering the question. Okay. Okay, so constants. Constants are useful for three important reasons. You might ask, why do we need constants? First, they give meaning to otherwise unclear literal values. So if you sit without a constant, if you think about this, oops. If you think about this, okay, if you don't declare this, you will just put 50 here, right? And as a reader of your code, I do not understand what that 50 is. It's simply a number. But if you put final size there, it makes your code much easier to read. It makes your meaning much easier to understand. That's what this means. Okay. First, they give meaning to otherwise unclear literal values. Okay. So if you understand that. Second, they facilitate program maintenance. Okay. So you declare this final size, and then you can use it all the way. You can say system.out.println, the final size is final size. And then you can say, add more to the room size, and then you can do final size plus 10, and then you can do final size multiplied by 4, etc. So if you decide the final size is 100, you only need to change this one place. You don't need to go and change other places in your code. That's what this means. It facilitates program maintenance. If you want to modify your program, the value, you change it in one place and all other places will be changed, right? If a constant is used in multiple places, its value needs only to be set in one place in your assignment. Third, they formally establish that a value should not change, avoiding inadvertent errors by other programmers. So if you say this is a final, then other people who work on your project look at this and they know I should not change it. It's a final, okay? Any questions about this? That's the benefits of a final variable.
Can you just go back to that slide for?
Which one? This one?
One more.
This one?
The other way. The other way.
This one? Chris?
Yes, ma'am. That.
Okay. And what's your question?
I'm just copying information down.
Oh, you know you have access to this, right? It's
I do. I do. I'm just reinforcing it by seeing it, writing it.
Okay. Okay. So now let's talk about print. Are you done with writing?
Yeah, I got enough of it.
Okay, good. Let me just.
Are we going to discuss the third reason, or did we already go?
Okay, they formally establish that a value should not change. That means I think I discussed this. So here, when you see this, okay, if I write a program, I write part of the program, and you as another group member review my code and add to it, you look at this and you think, oh, this is a final, I cannot change it. It's just as simple as that. That means this is a final variable. Do not change the value of it. And so when you use it, you know it's a final value. That's what this means. Okay.
Okay, thank you.
Mm-hmm. Primitive data types. Okay, so just now you asked me, are there how many data types did we discussed. We discussed just one just now. I think we discussed only int. Now, there are actually 8 primitive data types. What does primitive data types mean? Primitive data types means they come with the language. They are built into the language, okay? So there are 8 of them. 4 of them represent integers. So we learned int, the most often used byte, short, int, and long. Okay, there are 4 of them. This is a very small number. This number can only be from -128 to +127. So it's a very small number, okay? If you have a number that's very small, you don't expect it to change to a larger number, you can declare it as byte. And short is 2 bytes, okay? And int is 4 bytes, long is 8 bytes. So we usually use int. Unless your number is very, very large, then you use long. So those are the 4 data types for integers, for whole numbers. And then we have 2 of them that represent floating point numbers, that's decimal numbers, real numbers. So float is 4 bytes and double is 8 bytes. Okay, larger, much larger. And usually we use double. Okay, one of them represents a character, which is char. That is something like this. That's a char. And this is something like this. Okay, this is something like this. And then one of them represents a Boolean value. Boolean. Okay, we will discuss that. It is only 2 values. I have a slide for that. So let's go in and look at the difference between numeric primitive types and their size. Okay, so if you look at this, byte only uses 8 bits. Remember, 1 bit is 0 or 1, right? It only has 2 values. So 8 bits, that's the main value, that's the max value. Short, 16 bits, main value, max value. Int, 4 bytes, main, max. Long is very big, that's 8 bytes, okay? And float and double. Any questions about this? Okay, so from now on, you know that you can represent integers and double and floating point values and char values. Okay, so let's look at that is that, right? You understand that? Any questions about this, everybody? No? Okay. A char variable stores a single character. Character literals are delimited by a single quote, So when you declare it as a char, and the value should always be within single quotes. Okay, remember, what is this, everybody?
Next line.
Next line, new line character. So even though you have 2 symbols here, but it's 1 character, it means next line, right? That's the double quotes, right? Okay. So notice you must have that. A digit, now it's not a digit anymore. It's not a number anymore. It is a char character, a char value. Okay, so you declare the data type is char, and that is the variable name. And this is the value. You assign that value there. It's just like you have this memory location and you put the value there, okay? What is this, everybody?
Space?
Here, what is that?
Just representing space.
A space, yes, that is a space. Note the difference between a primitive character variable, which holds only one character in single quotes, and a string object, which can hold one or more multiple characters in double quotes. So let's look at this. Strings of characters are enclosed in double quotes, even if there is only one character. I need to move this so that I can see. Okay, if it is enclosed in double quotes, it is a string, not a char. So this is a string. This is a char. Even though both of them have only one character, this is a string because of the double quotes. This is a char because of the single quote. Okay, that's very important to remember because they are of different types. Questions. Is this a valid statement, everybody? Look at the first one. Char C equal to A. Is that a variable?
Yes.
Yes.
Yes, yes, right? Because it's a char. That means it should be in single quotes, and that's the value. And the variable name is C. It's not very meaningful. I'm just saving time when I type. But when you write your program, you always make your variable name meaningful. Okay. And I also did this to deliberately confuse you. So this is a valid statement. What about this one?
No.
No. Why not?
Two characters.
Two characters inside.
Yes, because you have two characters. That's not okay. What about this one? The third one.
Elsa is correct.
Correct.
Yes.
All of you say correct? Okay.
Yes.
Okay, good. Correct, right?
Couldn't you also just use int and then C to equal A and then int A to equal AB?
Here, int?
Yes, like wouldn't
No.
it? No.
No, because int requires a number, and this is not a number.
Oh, gotcha. Okay.
Great question, though. That means you are thinking about this. That's great. Okay. For int, it has to be a number like this. That would be good. Okay. And this is okay, you said, right? Okay. What about this one?
No,
No.
no character
Because-
symbol.
Yes, because you already said AA is a char variable and you are assigning a string to it. Not okay. What about this one?
Yes.
Yes.
Yes, everybody. Everybody, even though you are not talking, please think, right? Try to answer your question. Yes, this is okay because I think I meant it to be a space. So that's a space, and this is a char type. It's declared as a char, so you can assign a space to it as long as it's single quote, right? Okay, good. Any questions about this?
Thank you for clarifying about the double A being considered a character, because that caught me off guard a little bit. I thought
This one?
each one, yeah, I thought each one had to have char in front of it. On the
Here?
left. Yes, I thought they all were supposed to have a char, like,
Okay, okay. Now here is the thing. I don't have a char here because of what? Any answers?
It was
It's
previously
already-
stated in the line before.
Yes, very good, because it's already declared here, right? You're just using it. So that location is already a char, and it's named AA, and now it has C in it after this statement. And then when you come to this statement, you are simply trying to overwrite this one, and it's not okay because it's double quotes.
okay,
And then when you
thank
come here, you are trying to overwrite that one. That's okay because it is char. So, okay, any other questions? No? Okay, let's continue. This is here, it blocks me. I cannot see. Character set, what? I don't see it. Okay, coding, I think. A character set is an ordered list of characters. with each character corresponding to a unique number. A char variable in Java can store any character from the Unicode character set. Unicode character set. Okay, this is the coding scheme. The original coding scheme, I'm not elaborating a lot here, but the original coding scheme is called Ascii. That's American Standard Coding Information Interchange. Ascii uses 1 byte, just 8 bits to code a character, okay? Unicode, because 8 bits, you remember 8 bits can do what? 8 bits, this is how many values it can represent. So 8 bits can only represent actually 127 values. Okay, 128, 127 values. So that's not enough to represent all the the symbols in the world of the world languages. So now we use Unicode, which uses 16 bits. That's 2 bytes. And 2 bytes is very large, right? So it can represent enough. It has enough different symbols to represent the characters in the world languages. So now we are using Unicode character set. And Ascii is only a subset of Unicode character. So basically what you want to remember is you use Unicode character set, Unicode coding scheme to make sure that any symbol in any language in the world can be represented. Okay, and it uses, why is that possible? Because it uses 2 bytes, which is 16 bits, which is large enough if you change the arrangement of the ones and zeros. Okay, the Unicode character set uses 16 bits per character, allowing this many different unique characters. So basically, let me see if I have it. I don't? Okay, I don't. Okay, let me give you an example. Basically, it's like this. You know, if you have 2 bits, this is the different combinations. If you only have 2 bits, right? So if you use 2 bits, how many different characters can you represent? 4. If you have 3 bits, then you can have this, and then this, and then this, and then this, right? And then this, and what else? This. So if you have 3 bits, you can have 8 characters. So you arrange the zeros and ones differently. You have those permutations. And that therefore you can use this to represent black, this to represent white. That's what the the RBG represents. Okay, so
hold on real quick. I can't see anything that you wrote. I don't know if I'm the only one.
Can you not see what I write? Everybody?
I see it.
I can see
You
it.
can see it.
Yeah, I can see it.
So you can see it. So Chris, it's you yourself cannot see then. I don't know why.
The Zoom screen actually was covering everything that you wrote, but I just moved it over, so I'm good. Sorry about that.
Okay, so this is the 8 different combinations, right? That means if you have 3 bits, you can represent 8 characters. Think about it. If you have 16 bits, that means it's 2 to the 16th. That is this number. It can have this many unique characters. That's why we use Unicode to represent the characters, okay? It is an international character set containing symbols and characters from many world languages. Any questions, everybody? Okay. So the Ascii, I am talking about it here. The Ascii character set It's older and smaller than Unicode, but it is still quite popular. It uses 8 bits to represent a character, and therefore can only represent 256. 2 to the 8, that's 256 characters. It's a subset. So basically what it means is that if you want to represent a character originally using ASCII, you will do, let me think, A. Okay, A should be this. This is A. This is this character, how it's represented. So ASCII would represent it like this. Unicode would simply add the leading zeros there. So this would be Unicode. Okay, this is ASCII. So it's the same coding, except when you have more space and you don't have a value there, you just add the leading zeros there. So this is the Unicode set, and this is the ASCII set. That's why we say the ASCII character set is a subset of the Unicode character set. Okay, any questions, everybody? But if you are coding a Chinese character, for example, this variation is not enough. So what do? You use this part. That's why we use the Unicode character set coding scheme. Okay. So uppercase letters, lowercase punctuation, digits, and special symbols, control characters, etc. Okay. No questions? Okay, now what data types have we discussed, everybody? Give me one.
ASCII.
Data type. Int and
Char.
char and
Float.
what?
Float.
Float, double, byte, short, long, right? Okay, now let's talk about Boolean. Boole is a mathematician, I think. Okay, so this is in honor of him. A Boolean value represents a true or false condition. The reserved words true and false are the only valid values for a Boolean type. So if your variable is a Boolean type like this, you can only assign false or true to it. You cannot assign 12 or 3.14 or yes to it. You cannot do that. Those are all wrong. The only value you can assign is true or false. Okay, and this is wrong. Any questions? So for a Boolean, there are only 2 values. How many memory space do you think it needs?
4.
No, just 1 bit. You know, you remember we said ASCII character needs 8 bits, right? For a Boolean, it needs 1 bit because that can be 0 or 1. And this is true, this is false. That's it. So it needs very, very little memory, true or false. Okay, questions?
Dr. Z,
Yes.
when we talk about 3.14, are we talking about pi or is it just?
Oh, when I use 3.14, I'm just using that number because that's the very first number comes to mind. It is pi, but it's just the first number that comes to mind. I can use 10.56, but it doesn't come to my mind that often. So when I give you an example of a double, this is just the number that comes to me. Yeah. Okay. No special meaning because it is pi. I think I just, yes. Okay.
Okay, because it was earlier in the notes, so I didn't know if that was a correlation, but thank you.
Yeah, it is because that number comes to me. Yes. Okay.
Yes, ma'am.
Okay. Any questions, everybody? Any other questions? Okay, so you understand this, right? Let's go to the next slide. Expressions. Okay, let's talk about expressions. Why is this so? I cannot hide it. Okay, expressions. Go down. An expression is a combination of one or more operators and operands. For example, assuming that x and y are two variables initialized, they have values, the following would be arithmetic expressions. Okay, so this is addition. X and y both are variables, int variables, and they are declared and they have values. Division and multiplication. So we call these arithmetic expressions. Okay, they compute numeric results and make use of the arithmetic operators. Okay, so addition, subtraction, multiplication, division, and remainder. So these two are a little bit, they need more explanations, but these you understand very quickly. If either, okay, here it's very important, everybody, notice this. If either or both operands, okay, operands, these are operands, right? X and Y are operands. The plus sign is the operator, okay? If either or both operands are floating point values, what are floating point data types? Everybody, what are the two floating point data types?
Float and double.
Yes, very good. Float and double. Yes, float and double are the floating point values. That's the data types for decimal numbers. If either or both are floating point values, then the result is a floating point value. Okay, look at this. Double divisor. So even though this is a 3, but it is a double. So it's actually, when the computer stores it, it makes it into 3.0. Okay, and double dividend is 5. Once again, this dividend in that location, when this executes in the location, it will be 5.0, not 5. Okay, and quotient is equal to dividend divided by divisor. So dividend is 5.0 and divisor is 3.0, and that will give you 1.6666, etc. Why? Because both of them are double. The result will be a double. Okay, that's what this means. Now let's look at this one. This is an int. Okay, and this is a double. And one of them is an int. This is an int, but this one is a double. So the result is also a double. If either or both, okay? So if one of them is a double, then the result is a double. However, if both operands are integers, then the result is an integer. The fractional part is discarded. So look at this, int, int, and it's double. It's an int, that's correct. Okay, int, int, it's an int. The fractional part is discarded, remember. So if you do 8 divided by 12, that's it, right? You don't do the fractional part because it's discarded anyway. So that's the result. Any questions about this? This is where it's a little bit confusing to you, because in math, you always get the accurate result. But in computer science, it depends on the operands. If both of them are int, the result is int. Questions, everybody? So what is the result of this? Hello?
0.
0.
0? Let me give you again.
3.
3.
3, right? 3, yes. Okay, it is 10 divided by 3, that is 3. So this is 3. And what about this?
Zero.
3.
Say it again.
Is that a decimal?
That is a decimal point. I'm stressing it. It's a big decimal point, everybody.
10 divided by 3.0.
Zero.
Maybe 3.0.
Yeah, 3.0.
3.0. Okay, I'm making it so big that you can see, and gradually it's as big as the 0. So what data type is this, first of all?
Double.
Double or a float.
Okay. Okay, by default, the system will treat a real number as a double. It doesn't treat it as a float. So by default, it treats a whole number as an int, not a byte, not a short, not a long, but an int. Okay, so int and double are the default types. So what is the value of this? Go back to your rules.
3.0.
I'm sorry?
3.33333333.
Yes,
Oh,
that's
yeah.
correct.
Yeah.
3.33 forever. Why? Because one of them is a double. So, you know, computer science is very logic-based. So whenever you have doubts, always go back to the rules, and it just accurately, precisely follows the rule. So if either or both operands are floating point values, then the result is a floating point value. And that's why if you have 10 divided by 3.0, it gives you 3.333, even though this is a 0, but 3 point, okay, that makes it a double. Okay, now what about this? Everybody, what about this?
Would that be the same also, 3.333
Yes,
infinity?
that would be the same. It would be 3.333, etc. Because one of them is a double. That's very important. While this would give you 3 because none of them is a double. Okay, that's important to remember.
So you can
Okay,
have a
that
double
is
and a
division.
float on either side.
Go ahead.
You can have it can be a double or float on either side.
Yes, yes. But if it's a number, by default, the system treats it as a double. It's a double. It's not a float. Unless you do this, then the system will treat it as a float. But if it's a float, it's the same. If one of them, because if you look at the rule, it says floating point values, right? That means it's a double or a float, because floating point values are double or float. But if it's a value, by default, the system treats it as a double. That's what I'm saying. Okay.
Thank you.
Any other questions?
One more question.
Mhm.
So if it's going to automatically default to a double, what are we? So then, what's the rule to make it a float, or why do we even have float if it's just if a double is going to be able to get us there?
Okay, you can say where is it? Okay, unless you say float f equals to 3.4, then now when you use f, it's a float. But if it's a number, if it's just a number, the system automatically treats it as a double. That's all it is. If you declare it as a float like this, okay, now whenever the system uses this, it knows it's a float. Does that make sense?
Could you declare that as a double?
Yes, yes. And by default, usually people, instead of using float, they use double.
So why have doubles if you only need the one? Like why have a float and a double if you can get by with just a double?
Uses 4 bytes. Double uses 8 bytes. If you are doing really a lot of calculations, and some of them use smaller numbers, some of them use bigger numbers. You want to differentiate them because this uses less memory. It uses 4 bytes. So it's like a space, right? You have this space for a float, and then you have this space. It doesn't. You have this much space for a double. So it's half the size. That saves memory. It's all about memory when you do float.
That makes sense then. Okay.
And also double is more precise, everybody. Okay. So if we go back here, I did not elaborate on this. Okay. So if you could come here, let me make this go up. So if you look at this, and that's a great question. Okay. So float uses 32 bits. So it's smaller, right? And look at these exponents. So float is much smaller, and double can store a much larger number, right? Look at this range. What a big difference. It's more than half because it's exponential. And and this also makes a difference. Float can only store 7 significant digits, while double can store 15 significant digits. So if you have a number like this, you see 3.14 also comes to mind always. So it can only remember 7. That's what it remembers.
So is that kind of like the difference between a cheap calculator and an expensive
maybe
scientific calculator?
And this doesn't matter anymore, these digits. But if it's a double, then it will matter. $15 of them will matter. Does that make sense, everybody? So that's the difference between float and double. One, float is smaller. It can also because its size is smaller, it cannot hold a bigger number. Double can hold big numbers. And also the precision for float is only 7 digits. After the 7 digits, the others don't matter anymore. For double, 15 significant digits. Only after 15 digits, they don't matter. And that is that. So let's go to, I believe you understand that now, right? Okay, let's continue with this. Okay, now we understand the division. Let's look at this modulus. We call this modulus or remainder. Okay, this operator is called the remainder operator, or you can also say the modulus operator. Okay. So 14 remainder 3, just as its name says, remainder, we are looking at the remainder. 14 modulus 3 or remainder 3 means you are doing 14 divided by 3, that's 4, and the remainder is 2. This is the quotient, right? This is the remainder. So when you do this operation, you are looking at the remainder. And 8 modulus 12, you have 0 as the quotient, and the remainder is 8. That's the leftover. We are looking at the leftover. So if you look at this expression, okay, this is 12 divided by 3, that's the result. 12 modulus 3, that's the result. Okay, look at this. 14 divided by 3, that's the quotient. 14 modulus 3, that is the remainder. So there you have it. Any questions? This takes a little bit of time to get used to because you didn't have this idea before. So you just need to wrap your mind around it.
Is there like another example you can show, or maybe
give me a you tell me what other examples you want me to show. I'm asking you this because okay, another example. Let's see. Yeah, let's look at another example. What does this give you?
3.
3. Okay, what does this give you? What's the result of this?
2.
2, right? Okay, 2. Okay, so what does this give you?
30.
Say it again.
30.
Yes, that's correct, because that gives you 30. Okay, that's the modulus, and that is division. Does that make sense, everybody?
So
Go ahead. Go ahead, Kevin.
I'm sorry. I was just trying to reread the bullet point again because I'm not getting it, but we can still press on.
Yeah, let me give you another example. Okay, 7 divided by 2. I'm using smaller numbers, so okay. What's the result of that?
3.
3. 7 modulus 2. What's the result of that?
And it says divide the remainder. So
Is it 1?
Is it 1? Yes, 1 it is. Right? 7 divided by 2. That is the quotient. Okay. Another example. Go ahead.
No. Yeah, one another example, please.
Okay. Another example. Let's do this one. 14 divided by 28. What is the result?
2.
0.
Or 0.
0, right? There is not enough 28 in 14. There is no 28 in 14, so it's 0. What about this?
14.
14, that's the leftover. Okay, everybody? So there you have it. Any, do you want me to give you more examples? Or when you have doubts, when you don't understand it, look at this carefully, right? This really gives you the ultimate explanation. This is the division. This is the modulus. This is the division. This is the modulus. So, okay, let's do some examples and don't look at them, right? Let's do them from our memory, understanding. I have to do this vigorously. Okay. I hope I don't destroy this whatever writing pad. Okay. Okay, now you can see nothing but red blood. Okay, so let's look at this. What are the results of the following expressions? What's the result of this?
I think 6.
One day before.
6. Do you all agree?
That's
It's
yeah,
6,
6,
everybody? 6?
Yes.
Yes.
6.
Okay. Because both of them are int. Okay, what about this one?
6.0.
Yes, because both of them are double, right? So 6.0. What about this one?
2.
That one would be 2.5.
2.
Yes.
Yes. Yes, 2, because it's integer division, and both of them are int. So you only look at the quotient and you discard all the decimal places. Okay. What about this?
2.5.
0.5.
2.5, because one of them is a double, so you get a double result, accurate result. Okay. What about this?
0.
0.
0, everybody, because there is not a 10 in 4, and both of them are int, so the result is int, right? And what is this? 2.5. And this one, what about this one?
0 still.
0.
I think it'd be 0.4.
0.4. Anyone else who thinks it is 0.4?
I
Yes.
agree.
Okay, 0.4 it is. Why? Because one of them is a double, everybody. 4.0, 10, you have 0, and then you have 4, right? So it's 0.4, that's correct. Because one of them is a double. And always remember that rule. If one of them is a double, then it's a double result. What is this?
0.
Do you all agree?
Yes, 0.
Yes, 0. Okay, so this is 0. What about this?
1.
1. Yes, because
3 times 3 is 9, and then you got 1 left over.
yes. What about this?
0.
0.
0. 3?
3.
3. Is it 0 or 3?
3.
3.
Like 3.
Okay. 0 is the quotient, 3 is the remainder.
Oh.
Okay. Okay, good, everybody. It seems just from your answers, you understand it. I don't know if the students who did not answer, you know, it's difficult in Zoom to answer because you have to remember to press the unmute button. But okay, I do have the explanations here. If you didn't quite understand it, look at the explanations there. Okay. Okay. Operator precedence. Let me look at the chat, and I think it might be your answers. Okay. So some of you. Okay, good. Okay. So let's look at this. Operator precedence. That means who comes first. Look at this. Okay. Result. Suppose it is declared already. And you look at this expression, right? You know from your experience in math, you know what comes first. Division, multiplication always come first before subtraction and or subtraction or addition. So you will do this one first, right? Do that one first, and then do this one second, and then do the whole thing subtraction third. So division, addition, and subtraction. Any questions? And here is the precedence level. Any questions? Okay. So here, unary plus, unary minus. This is really is it that this means the positive, I think, right to left, positive, or it means the plus plus, and we will look at that. Okay. Yeah, that's the that's not the negative positive, that's the single unary plus or unary minus, and we will look at that later. Okay, so this comes first, they always come first. And then these, right? String concatenation always comes after these, right? Okay, so, and then notice that assignment comes last. It has the least priority. Why? Because you have to finish this expression evaluation first. So always remember we said always evaluate the right-hand side and then assign the result to the left-hand side. So this always comes last. Any questions? Arithmetic operators with the same precedence are evaluated from left to right, but parentheses can be used to force evaluation order. So if you have x minus y plus z minus w, then you always go, because they have equal precedence, you go from left to right. You do this one first, and then this one, and then this one. Unless you do this. If you do this, you will do this one first, and then you still do this one, and then this one, right? Okay. So in what order? Let's look at this. If I ask you this question, okay. What order do we do this? How do we do this? Which one do we do first?
A and B.
Yeah, very easy, this one, right? Okay, that's that. From left to right. And what about this one? What do we do first? The second one. Hello?
The division.
Would be the same, right?
Oh, D divided by.
Yeah, A plus B divided by C.
Why don't you do the division, multiplication?
It's all, it would be all plus. It would be like 4 pluses. Are you doing the
Okay,
first one or the second one?
we are doing the second one.
Second one.
Oh,
Multiply
Finish.
first.
Oh, you'd multiply first and you
It would be
divide.
B times C, then D divided by E.
So we do multiplication first, and then what do we do next?
Division.
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 And then
Addition, and then
Addition.
subtraction.
and then yes. Okay, always remember the precedence. Multiplication first, division second, addition next, and minus next. Okay, last. What about this one? Third one. We are done with that.
B plus C.
B plus C first, and then
Division.
And
I
then
cannot hear-
A divided by B plus C.
yes, and then
D divided by E.
modulus E, and then
Subtraction.
then subtraction. Okay, this one. So we are done with this one. What about this one?
The inside subtract.
Then
The addition
Addition,
and the parentheses. And then the multiplication.
multiplication, and then division.
yes. Okay, good. Let's go on. Let's look at this example, everybody. Temp converter. This is a program, right? Okay. Class header, beginning, ending, and method header, beginning and ending. Okay. Final. What does this mean? You remember. What does this mean?
Constant.
Not changeable, right? Not changeable. Okay, and this also means not changeable. And this is an expression, both are double, so the result will be a double, 9.0 divided by 5.0. Okay, and declare a variable double and an int with initialization 24, right? Okay, Fahrenheit, which is a double, this is a double, equals to, so we evaluate this first. What do we do first?
Multiply.
Multiplication,
Multiply.
and then, yes. Okay, Celsius temp, which is 24, right? Multiplied by conversion factor, 9.0 divided by 5.0. Do you want to do it? 9.0 divided by 5.0. This is 1. 8. Oh, this is easy. right? Okay, 1.8. And plus, what is base? 32.
32.
Yes. And so this, after you evaluate this, 24 multiplied by 1.8, and then add 32 to it, that is your Fahrenheit. And then you output, oh, where is my pointer? Okay, then you output this string concatenated with this int. This is int, right? Yes. Okay, and this string concatenated with this double. And let me see the result. I don't have the result. Oh, I don't have the result here. Okay, but that is this program. Any questions, everybody? I don't have it, huh? Okay, but do you understand this program? So the output will be this plus whatever that is, and this and whatever that is. That's the output, okay? Okay, so the assignment operator, let me see, what time is it? Let me see, let me pause for. So this is what you will do. Any questions, everybody? Okay, so it's just meaningless calculations here, but just to practice what we learned, right? Okay. I will let you do that. Okay, so first we want to declare a final variable named age, declare another variable named gap years. So I'm going to do that. Final int age, and because it's final, we want to say that. Okay, and then we want another final variable int gap years, right? And let's say in 20 years or 25. Okay, and then declare a variable named new age. So int new age. And we don't initialize it. So that's declaring the three variables. And then display new age in gap years. So that means I'm right now 34, and in 25 years I will be 59, right? Not me, but this person. So that would be the new age. What I do is I will do a calculation, age plus gap years, right? Okay, that will give me the new age. Notice that I'm using it here. I'm not changing it. I'm just using it, right? Referencing that. And now I'm going to display system.out.println in, right? In how many years? In gap years. In this many years, if it's 20, that would be in 25 years, I'm going to go to the next line. Okay, and concatenate it. I will be not age, new age, right? New age. Concatenated with strings, years old. That is it, right? Okay, let's display. Okay, so in 25 years, I will be 59 years old. And notice there is no space between B and 59. So I will add a space here, just right here, add a space. And this will do, right? So in 25 years, I will be 59 years old. And then I want you to display do some crazy calculation. Precise result of your age divided by gap years. So I will just display it. Or you can do some int, declare some variable and put it, but I will just display it because I don't have much time. So what did I say? Age divided by gap years, right? I will say new age. How about that? My new age divided by gap years by this. I don't have a specific instruction for this, so I'm just going to do it. Is plus, I will put a parenthesis there just in case. So new age divided by gap years, right? That's it. And I also want to display the remainder. So new age modulus by gap years is, so here I'm going to change it to modulus. If you didn't understand this, that's fine just now, because as I said, it's some crazy calculations, meaningless calculations. So, okay, in 25 years, I will be 59 years old. My new age divided by 25 is 2. Okay, my new age 59 divided by 25, that is 2. And my new age modulus by 25 is 9. That's the remainder, right? So you can see the that. And just to illustrate the purpose, the third function of a final variable, I can change my age to 60, right? Change gap years to 30. And then all these, you don't need to change them. You change it in one place, and then that number will apply to all these new places. That's the third benefit of a final variable. If you remember, we discussed that, and one of you asked, right? So now the calculation is different. In 30 years, I will be 90 years old. My new age divided by 30 is 3. Then my new age modulus by 30 is 0. So that's that, everybody. I'm going to stop sharing now. Okay, it's a meaningless calculation, but we did some, it's just some exercise. I'm going to stop recording right now. Okay.